Okay, this is lesson 82, area of a circle. And we're going to review at first some of our polygons where we find the measurement or we find the area by multiplying two perpendicular dimensions, two perpendicular dimensions. And for a rectangle, we have a length and we have a width. And we know to find the area of a rectangle, we just multiply those two dimensions together. Length times width gives you the area of a rectangle. Here we have a parallelogram. Again, we have two perpendicular dimensions. We have a base and a height. To find the area of a parallelogram, we multiply those two dimensions together, base times height, and we get the area of a parallelogram. Here we have a triangle. It also has two perpendicular dimensions. Remember, perpendicular means meeting at a 90-degree angle. Here is your base, here is your height. And remember that for every triangle with the same base and height of a regular, whether it's a rectangle or whether it's a parallelogram or what have you, if we have that quadrilateral figure with the same base and height, a triangle is half of it. So the area of a triangle is 1/2 base times height, or we can say base times height divided by 2. So that is the formula for finding the area of a triangle. Today we're finding the area of a circle. A circle doesn't really have perpendicular dimensions, but we know in a circle we know that this dimension right here is the radius. So it actually does have perpendicular dimensions. So we know that this area right here, if we were to find the area of this whole thing, it would actually be a square like that, right? And r times r would give us r squared. Oops, I made a capital R. R squared. But it's not perfect because we know that there's a curved area in there that's missing. But go with me on this because we're going to find the area of a circle in just a moment. So let's take this r squared, and I've cut a couple of other ones. And if we're thinking about the area, you know, we've covered up the area of this circle with 4 of these squares, 4r squared. But a circle, as we know, is not totally 4, right? 4 would be too much. And 3 would probably be too little. So somewhere between these two things, it's going to be between 3 and 4 r squared. Now that kind of seems funny, doesn't it? Well, let's give us a number. Let's say that this r is 3. If we were to multiply 3 times 3, we'd get 9, right? All right, and 9, and if there was 4 of them, like we have these 4 squares, like let's say that we said that this was 3, so we have 9 here, 9 here, 9 here, and 9 here. 4 9s, 4 times 9 is 36. Well, it's not quite 3 9s, or three 9s, which would be 27. So somewhere the area of a circle that has a radius of 3 is going to be between 27 and 36. Well, we know between 3 and 4 actually has a name or a figure, and that is pi. That is 3.14. That is between 3 and 4, isn't it? Yes, it is. So if we take a look at our circle again, we are going to use r squared as part of the formula. And we're going to say that the area of a circle is equal to pi, which is between 3 and 4, which we found between 3 and 4 squares, times r squared. And that is the formula for a circle. So if we did find out what the answer was for r equaling 3, we would multiply 3 times 3, which is 9. That's our r squared. And then multiply it by pi. If we gave pi a value like 3.14, it would be 3.14 times 9. And then you just multiply out like normal and put our decimal into place, 2 places over, and that would be the area of the circle. Remember before I was saying that the area was between 3 and 4 squares. 3 squares of 9 would be 27, and 4 squares would be 36. Notice what the answer is. It's 28.26. That is in between those two. It's between 3 and 4 squares. Between 3 and 4 squares. Because that is a square. So we've just learned that the formula for the area of a square is area is equal to pi r squared. That is the formula. All you do is plug in the numbers that you're given. So let's take a look at example A. Example A shows a circle with a radius of 10 centimeters. And it says use 3.14 for pi. So if we have this, we just plug that in right here, and we have this amount for pi. We're going to put that in there. So we just take that formula and we just substitute our numbers in there. So pi is 3.14. R squared is going to be 10. That's our radius squared. What's 10 squared? That is 10 times 10, which is 100. So 3.14 times 100 equals 314. Problem B has a circle with a radius of 7 inches. And it says use 22/7 for pi. Again, all we're doing is substituting our values in the formula. So area of a circle is pi r squared. Now it says to use 22/7 for pi, so we're going to substitute 22/7 for pi. We have 7 as our radius, so it's 7 squared. So 22/7 times 7 squared. So that's 22/7. 7 times 7, not 7 times 2, but remember squared means we multiply that number by itself. 7 times 7 is 49. I'm going to go ahead and put 49/1. Then we cross cancel. 7 goes into 7 one time, into 49 7 times, and here's our problem, 22/7. Not 22/7, but 22 times 7. So 2 times 7 is 14, carry our 1. 2 times 7 is 14, plus 1 is 15. 154, and it's in inches, 154 inches squared. This last problem, C, has a circle, but this time it has a diameter. The diameter is 12 feet. And it says use pi for pi. Remember when we had that, when we were finding the circumference of circles? This is when we celebrate because life is going to be easy. Again, we substitute. Pi for pi, we don't have any numbers there, so we're just going to put pi. Radius squared, they gave us a diameter, not a radius. So how do we figure out the radius when we're given a diameter? We take that number and we divide it by 2. So 12 divided by 2 is 6. So our answer, or our number is 6 squared. Can't do anything here. They didn't say put a number in there, so it's just pi. 6 squared, all you have to do is multiply 6 times 6, and 36, and that is your answer. Now, a proper way to write that is to really write 36 pi, and it would be feet squared, and that is your answer. Remember, that's when you celebrate because it was pretty easy, wasn't it? Okay, now we're doing our lesson practice. And this is problem C. What it said for our lesson practice is just take C, and it says instead of using pi, instead of leaving pi as pi, it says use 3.14 for pi and calculate to the nearest square foot for the area of the circle in this example. So we've already done all the work. Now all we have to do is substitute 3.14 in for pi. So we always want to put our longer number up top, even though we have it second in the problem. So we're going to multiply 3.14 times 36 to get a number, and then we're going to round it to the nearest square foot. So we just multiply 4 times 6 is 24, carry our 2, 1 times 6 is 6, plus 2 is 8, 3 times 6 is 18. Put a 0 as placeholder. 4 times 3 is 12. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. So we're going to add all this up. 8 plus 4 is 12, plus 1 is 13, 10, 11. We want to put our decimal in place. And it says round to the nearest square foot. Well, because this is a 0, we're just going to round that to 113. So it's 113 feet squared. And that's the answer for A of your lesson practice, using C as the example. Problem B has a circle with 8 centimeters as its diameter, and it says to use 3.14 for pi. So we take our formula, area is equal to pi r squared. Up here, it says to substitute 3.14 for pi, so we're going to substitute 3.14 for pi. The radius squared, notice that they gave us a diameter. Remember, the diameter is radius times 2, and so to find the radius, we divide by 2. So 8, the half of 8 is 4, and it's squared because it's radius squared. So then we just do the math. 3.14, area is equal to 3.14 times, remember this is 4 times 4, not 4 times 2. Remember, it's squared, not times 2. So now we have to do our math. 3.14 times 16. 4 times 6 is 24. That is 8. That is 18. 4 times 1 is 4. 1, 3. Now we add 12, 10, and that would be 5. Decimal goes right here, and it's 50.24 centimeters squared. That would be the area of this circle right here. Problem C, it says leave pi as pi. Remember, when we have these, we celebrate because life is easy. So area is equal to, and pi is pi, so we put that there. And then we have times 4. That is a radius, so we can do that right there. Notice, looks like the problem that we just had before, except for we don't have to solve it. So A is equal to pi times 16. And writing it properly would be 16 pi centimeters squared. And that is all you do. That's why you celebrate. See how easy those are when you leave pi as pi? So when you see pi as pi, celebrate. Woohoo! Here's problem D. We have 8 centimeters as a diameter. Do you see a little pattern here? We have the same thing, just 3 different ways. But this time we're going to do 22 over 7. We're going to use that as pi. So again, we substitute. Instead of pi and instead of 3.14, we're going to put 22 over 7 for pi. Times, and we already know that is 4 squared. We can do that. We can just write 16 here and 22 over 7. Put 16 over 1. There is no cross-canceling that we can do here. This is not a fun problem. Just saying. So we're going to have to multiply 22 times 16. And 2 times 1. 2 times 1 is 2. And because we didn't carry the second time around, it's 2, 5, and 3. 352. Is that? Yeah. Okay, so this is equal to 352 over 7. So now we have to take 352 and divide it by 7. 7 goes into 35 5 times, which is 35. 0, bring down the 2. 7 goes into 2 0 times, which is 0. And then we can just write a remainder, 50 2/7 centimeters squared. And that is your answer for finding it when 22/7 is your pi. I hope this was pretty easy for you. If it was not, maybe re-go over some of the lesson and just pause at each point and try to understand each section.